Hey everybody, this is another video in the series on atomic structure and nuclide symbols, and in this video we're going to be doing a few sample problems and our first chart problem. Buckle in, it's going to be fun. Here we have two nuclide symbols without the atomic symbol given, so we don't know what atom it is. Maybe we can do what the question says, and after we determine how many protons, neutrons, and electrons there are, we can name the element. But very straightforwardly, determining the number of protons becomes something that can happen. So we know that the number of protons is 16 because that's this number here. Okay, now the number of neutrons, here's a neat trick for determining the number of neutrons, because the number of neutrons is related to this number here. So it's the number of protons plus the number of neutrons equals this. Well, if the number of protons is here, 16, and this is the total, what I can do is I can set this up just like a column math problem that you used to do in 3rd or 4th grade, and you do this and you get 33 minus 16 is 17. So the number of neutrons in this problem is 17. And now the number of electrons becomes a little more straightforward, because here, notice there's no value here. This is indicating that it's neutral. A neutral atom is always going to have the same number of protons as electrons. So now we'll come over here to the second problem and we'll do the same thing that we did with the first. The number of protons is the most straightforward of the ones to answer because that's just this number in the bottom corner. And now in order to determine the number of neutrons, again, we're going to set up our column math. We'll do 88 minus 38, and that's a 0 and 5. So the number of neutrons here is equal to 50. And then again, the charge here, it's 0. So that doesn't mean that the number of electrons is 0. That means that the number of protons equals the number of electrons. These two things cancel each other out, meaning that there is no charge. So the number of electrons in this case is 38. Now it asks us to name the element, and so in order to name the element, we get out our periodic table, and we will see that element number 16 on the periodic table is the element sulfur. And then we look at the periodic table and we find out that element number 38 is strontium. I think we're ready to do our first chart problem. Okay, so now here is a chart problem where we can take the information that's given to us in the chart and fill out the rest of the table given the information that we just learned. So for this first column here, okay, we have to look at sodium on the periodic table, and we will get that the sodium has 11 protons. Now again, notice that there is no charge here. The fact that there's no charge here means that the number of protons equals the number of electrons, and so there'll be 11 electrons. The mass number is the number of protons plus the number of neutrons, so that's going to give us the mass number here. 11 plus 23 is going to give us the mass number of 34. The atomic number is just the number of protons, it's 11, and then the charge in this case, we compare the number of electrons to the number of protons, and they're equal, so that's going to give us a charge of 0. We also know from the nuclide symbol that there was nothing given, and so that also tells us that there is a charge of 0. So now we probably should finish the nuclide symbol. So remember, the number at the bottom is going to be the atomic number, and the number at the top is going to be the mass number. Okay, so now let's see if we can determine the number, the second column. Okay, I'll do this in a different color to make it a little more easy. So the number of protons here is 23, and the mass number here is 50. So we know that 23 plus the number of neutrons gives us 50, so this number should be 27. Okay, the number of electrons. Notice here that there is nothing given in terms of the number of electrons. So anytime nothing is given, we assume that the charge is neutral. So because the charge is neutral, the number of protons and the number of electrons is going to be equal. So that's 23. They cancel each other out, giving us a charge of 0. And now the atomic number is the same as the number of protons, so that's 23. This number is the same. This number is the same as this. Okay, so now we write the nuclide symbol. And so we look at the periodic table and we find out that element number 23 is vanadium. And we write the atomic number down here. We write the mass number up here. And we write the charge here as being 0. So now we continue. We do the same sort of thing. So number of electrons. If nothing is given, then we have to assume that the element is neutral. So if it's neutral, that means that the number of protons must equal the number of electrons. And again, I'll do a different color here. So that has to be 8. So that means that the charge is neutral, 0. And the atomic number is also the number of protons. Okay, so you see a pattern here that the number of protons is going to be, if it's neutral, the number of electrons and the atomic number. There's a lot of the same values here. And then the mass number is the number of protons plus the number of neutrons, and that's going to equal 17. So now we're going to write the nuclide symbol. We look at the periodic table and we find out that oxygen is element number 8, and we put the atomic number here, and we put the mass number up here. And now I'm not going to put anything in the upper right corner, because that's another way that we would write the nuclide symbol. If it's blank, we assume it's neutral. Okay, so now in the last column here, we're given a nuclide symbol and nothing else. Now we're going to fill out the column based on the nuclide symbol. So we can see that in the atomic number position, we have 27 protons. And then if we subtract the two, 60 minus 27, that's going to give us 33 neutrons. That's cool. And then there's nothing up here in this corner. So the assumption again is, if there's nothing given, that the number of protons is going to equal the number of electrons. So that's going to be 27 again. So that makes the charge on this neutral. Okay, now the atomic number is the same as the number of protons. That's 27. And then the mass number is given to us already in the upper left corner there, and that is 60. So there's your first chart problem. I hope it went well. Have a great day.